So we're going to be working through a bunch of problems using the chain rule. So our first problem, we got y equals 5 minus 2x to the negative 2. And we want to find the derivative, y prime. So here's how we use the chain rule. We take the derivative of the outside function. So kind of think of this as x to the negative 2 as the outside function, this whole thing in parentheses. So we're going to take the derivative of the outside, so we're going to bring the negative 2 down, leave the inside the same, subtract 1 from the exponent, so that's going to become negative 3. And now the chain rule says we multiply by the derivative of the inside. So the derivative of 5 is 0, and the derivative of negative 2x is negative 2. Okay, so we take the derivative of the outside and multiply by the derivative of the inside. And now it's just a matter of simplification. So this right here is negative 2. This right here is also negative 2. So negative 2 times negative 2 is positive 4. And then we have 5 minus 2x to the negative 3. And this is a perfectly valid answer. You can write this as your answer and it is completely correct, but you might also see this written in a different way, that we can use, we can get rid of this negative exponent. So we can write this as, so anything to the negative, to something out of the negative power is the same thing as 1 over that to the positive power. So this can also be rewritten as, so 4 times 1 over 5 minus 2x to the positive 3. Right, because anything to the power of negative 3 is 1 over that to the power of positive 3. And if you multiply across, so you can think of this as 4 over 1, we multiply the numerators, we get 4. And in the denominator, we just have 5 minus 2x cubed. All right, and that right there is our derivative. All right, so the next one, so we'll call this problem 1. We have y equals 2x cubed minus x squared plus 6x plus 1 cubed. And we want to take the derivative. So we're going to be using the chain rule. So y prime, so the derivative of the outside, we're going to basically take the derivative of the outside and multiply by the derivative of the inside. So the derivative of the outside, so we're going to bring down the 3. So it's going to be 3 times, and then we're not going to change any of this. Okay, and now we're going to subtract 1 from the power. That's the derivative of the outside, right? 3 keep this, and then now it's going to be squared. And finally, we multiply by the derivative of the inside. That's the chain rule. So the derivative of the inside, so we're going to have to bring down the 3. It's going to become 6x squared. So then the derivative of negative x squared is going to be minus 2x plus 6. And then the derivative of 1 or any other constant is just 0. So plus 0. So we don't even have to write it because it doesn't change anything. And that's our answer. So number 3 is a trig problem. Okay, so we have y equals sine squared x, and we want to find the derivative. Okay, so whenever you'll see this a lot of times with trig functions. You'll see them written as like sine squared x. So sine squared x or cosine squared x. You'll only see this with trig functions where they put the squared right here. Tangent squared x. What that just means is that's just an easier way to write sine of x squared. That's what that means. So a lot of times, it might get tedious to write it like this, where the parentheses and the square up here. So we just decide to put the square right there in that position. It makes writing it easier. Okay, so sine squared x, as we just mentioned, what that is that's sine of x squared. And now that it's in this form, we can take the derivative. So we're going to take the derivative of the outside first. So we're going to bring the 2 out front. So it's going to be 2. Leave this unchanged. Subtract 1 from the exponent. And now the chain rule says we got to multiply by the derivative of the inside. So we got to multiply by the derivative of sine. So the derivative of sine, we have to multiply by it. What is the derivative of sine? Well, the derivative of sine is cosine. So we got to multiply this by cosine x, the derivative of the inside. And that's our answer. The way you'll probably see this written is we'll probably omit the parentheses and just write this as 2 sine x cosine x. All right, so number 4 is we have y equals tangent of x plus sine x to the negative 3. And we want to take the derivative using the chain rule. Okay, so similar to before, we're going to take the derivative of the outside and then multiply by the derivative of the inside. So the derivative of the outside is going to be, so we're going to bring down the -3, so it's going to be -3 times, okay, so we're going to keep the inside the same, so it's going to be tangent of x plus sine x. And then we subtract 1 from the exponent, right? That's the derivative of the outside part, so it's going to become -4. Okay, but the chain rule says we got to multiply by the derivative of the inside. So we have to multiply by the derivative of tangent x plus sine x. Now, what's the derivative of tangent x? Well, there's a little trick that I know to find the derivative of tangent x. So the way it works is you go pst. So P S S T. Pst. And the way this works is the S's stand for secant, the T stands for tangent, and the P just means positive, so positive sign. So to find the derivative of tangent, we just cross it off. And this, what we're left with, is the derivative of tangent, so positive secant squared. So the derivative of tangent, right? So we said pst, we cross out the tangent, and what's left is our derivative, so positive secant secant, or secant squared. Okay, we're not done yet. That's only the derivative of the tangent. What's the derivative of sine? Well, we found it up here. The derivative of sine is cosine x. So plus cosine x. And that's our answer. You could bring the -4 and make it a positive exponent, but I think keeping it like this is fine for this one. So for number 5, we are asked to find the derivative of sine of cosine x. Now this one's a little bit different because our outside function is sine, whereas before our outside function was just like this -3 power, this 2 power, right? It was an exponent. But here our outside function is a trig function. So our outside function, let's write this down. So our outside function is going to be sine x. Whereas our inside function is going to be cosine x. Okay, so now we're ready to apply the chain rule. So we're going to take the derivative of the outside function and multiply by the derivative of the inside. So the derivative of the outside. So the outside function is sine, so the derivative of the outside function is going to be the derivative of sine. The derivative of sine is cosine. So I'm going to have cosine You always keep the input the same when you're taking the derivative of the outside function. You don't change it. And then finally, we have to use the chain rule, multiply by the derivative of the inside. So the derivative of the inside is going to be the derivative of cosine x. It's not sine x, it's negative sine x. Okay, so we took the derivative of the outside function, which is cosine of cosine x, and we multiply by the derivative of the inside, which is negative sine x. And now it's just a matter of simplification. So typically we like to write the negative out front, so it's going to be negative. And then we can write the sine x or the cosine of cosine x first, it doesn't matter. We'll just keep this one first because it's already there. So negative cosine of cosine x times sine x. Let's do another one like that. So in this one, we have y equals tangent of sine x. So kind of like the first one, let's identify our outside function and our inside function. So our outside function is going to be tangent. And our inside function is going to be sine. Okay, so we're going to take the derivative of the outside, multiply by the derivative of the inside. So what's the derivative of the outside function, the derivative of tangent? Well, remember, psst. Right? So whenever we're dealing with secants and tangents, we want to use psst to find the derivative. So to find the derivative of tangent, we just cross out the t. And what we're left with, positive secant squared, that's our derivative. So y prime. So the derivative of tangent is going to be positive secant squared. Right? We use psst, we crossed out tangent. What we're left with is our derivative. And then we always leave the input the same. And then we got to multiply by the derivative of the inside. So multiply by the derivative of sine x. So the derivative of sine x is cosine x. So we got to multiply by cosine x. And that's our derivative. The only thing I would do here is I would get rid of the parentheses around cosine x, make it look a little bit nicer. So I would write this as secant squared of sine x times cosine x. So number 7, we're now moving on to some exponential, or an exponential problem, ones with e's. So we have y is equal to e to the negative 2x. and we want to find the derivative. So finding the derivative of e to the negative 2x or any exponentials is extremely simple, even with the chain rule. Here's how we do it, is we just repeat the first part. So we're just going to rewrite the first part. So e to the negative 2x. And then we multiply by the derivative of the exponent. So we multiply by the derivative of negative 2x, which is negative 2. Now it's just a matter of cleaning this up. So it's going to be negative 2 e to the negative 2x. Let's do one more just to get the hang of taking the derivative of exponentials. So e to the sine x. Okay, taking the derivative of exponentials, extremely easy. We're just going to rewrite the first part. So e to the sine x, we're just going to rewrite it. And now we're just going to multiply by the derivative of the exponent. So the derivative of sine x is cosine. So our derivative is just e to the sine x times cosine x. And the final type of problem we'll tackle today is the derivative of natural logs. So the derivative of natural logs, at least I think, is a lot easier than the derivative of trigs. It's kind of like the derivative of exponentials. I think it's a little bit easier. So here's how you do it. So the derivative of a natural log is you're going to do 1 over the inside. So it's going to be 1 over the inside. So 1 over the inside times the derivative of the inside. The derivative of x squared plus x, so the derivative of x squared is 2x plus 1. So our derivative is going to be 2x plus 1 over x squared plus x. And our final problem for today is going to be, we want to find the derivative of the natural log of secant x. So like number 9, the derivative of the natural log is going to be 1 over the inside times the derivative of the inside. So how do we do the derivative of the inside? Well, remember, secant. Psst. So we're going to cross off 1, and our derivative is therefore going to be positive secant tangent. So the derivative of the inside is going to be secant x times tangent x. Okay, notice that we have a 1 over secant x we have a 1 over secant x here, and a secant x here. Those are going to cancel. So our derivative that we're left with is just tangent x.